Hi all. Good morning, good evening in whichever geographies you are here. Let me introduce myself and let's start to see what topic we will try to talk today. So my name is Kiran and here we are today to talk about logistic regression. So saying this, let's try to see what is that we try to cover in today's agenda. So we will try to talk what is regression, logistic regression, what and why, linear regression versus logistic regression, and we will try to see some use cases, and then we will try to see hands-on on how this logistic regression works. So in nutshell, we will try to understand for any kind of prediction what exactly is needed and how exactly logistic regression works, and we'll also try to compare how logistic regression is different from linear regression, and we will discuss about two use cases. So are we good, guys? Please confirm. Then we are good to start. Okay. Oh, okay. So I think Vikas confirmed, and we will also set few house rules. So as we talk, if you have any questions, feel free to put it on the chat window. I'll be more than happy to reply you. Okay. So saying this, we do same thing. Good evening. Hi Abhishek, welcome. Okay, so if you see and try to understand what is regression. So I understand we would have definitely known what are all the different types of learning, the supervised learning, unsupervised learning, reinforced learning, and if you have to talk about one particular segment, which is supervised learning, where we say that label data is the core crux for supervised learning. So what does it happen in supervised learning? Predominantly, whatever we are trying to understand or whatever we are trying to replicate, we have a supervisory information. In sense, somebody or some labeled information is available for us to take some decision. So this kind of learning where we have an additional help is supervised learning. Within supervised learning, we predominantly use two types of learnings, which is classification and regression. So if you have to see what is classification at a very high level, we are talking about bucketing. Is it A or B? Or is it male or female? And if you have to take an example, is it a valid email or a spam? So this kind of decision making is a classification. While coming to the other type is regression. So when we have to say what is regression, then regression is a predictive modeling technique. What do you mean by predictive? Which means anything which we can try to expect or anticipate based on some information what we already have collected. So that kind of expecting or predicting something for future is your predictive modeling, and for predictive modeling we use regression technique. So for example, if you have to say will it rain tomorrow, it's a prediction. What is the temperature tomorrow is a prediction, right? So we are trying to understand based on the given parameters what we have as of today, based on the weather, based on the month of the year, based on the geography where we are, all these considerations we try to take into account passively or actively, and try to say, given the month of August being in a subcontinent where it is a winter season or spring season, we probably say it might be X amount of degrees of Fahrenheit. So that kind of analysis where we try to predict something in the near future is your regression analysis. So if you have to read, it estimates the relation between a dependent, which is the target, and an independent variable, which is the predictor. So in our example of predicting the weather temperature tomorrow, we are all the parameters which we said, the month of the year, the continent, geography, everything is your independent variable. while the dependent variable is your actual temperature. So if you have to see a simple linear regression graph, you usually plot it on your x and y axis, right? And the values which we have collected over a period of time is your scatter, which we see this, and within the scatter, we try to put a linear relationship so it helps us to predict. I think we have a question. Let's try to see this. Okay. Oh, that was just an information. Okay. Okay, so anything coming back, so the values which we have collected with from past, we try to scatter. I think we have a question now. Okay, explain the dot meaning in the plot. Yes, because that's what we are trying to talk. Okay, so what we are saying is, for example, if you have to take and consider this x and y axis as your real estate value, where your x axis is representing the number of square feet in thousands, 5.5 or 5,500 square feet or 5,750 square feet, and y values is representing the price. Now, what we have done is, for a given particular area, with the transactions, what has happened, we are trying to scatter these dots. Now you are saying that, for example, a 5,750 square feet place is costing some 1 crore 8 lakhs, while a 6,000 square feet plot is costing, plot or a flat is costing around 1 crore 12 lakhs. So this is the plot, which is the data gathered from your history, which we try to put across in your two dimension. I think we have one other question. Okay, your voice isn't clear, Vipin. Okay, 1 second. Is it better, Vipin? Is it better, Abhishek and Vikas? Are you able to hear me now? Oh, okay, got you. Oh, okay, thanks for the confirmation. Now, so this dots are that scatter of information what we have collected from our experience or history. Then, given that, we try to do a fitment, which is your linear line. And for example, one of your friend or colleague comes to you and says that I have 101 crore 30 lakhs, then you probably say you would be able to buy something around 7,000 square feet. Or inversely, if somebody says I am looking for a property around 6,000 square feet, then you probably say it might cost you anywhere between 1 crore 10 lakhs to 1 crore 12 lakhs, which is linearly proportional. Here, if you see, for 7,000 square feet, it is concluding at around 1 crore 24 lakhs. So the input value is 7, the predicted value is 123.9. This correlation of finding things based on the data what is available is something called as regression. But here, if you have to see, the dependent variable is always directly or indirectly, it is trying to determine its value based on your independent variable. So saying this, then what is logistic regression? I think we have a question. Let me pick that. Okay. So how do we plot and fit the line? Okay. Because this particular thing, whatever we say here, fitting the line is something part of the linear regression. If you happen to see my video on linear regression, you will get that. But just to get a brief thing, basically you have your y is equal to mx plus c, which you determine your calculation to see the actual fitment. And with the best fitment, you try to do an r squared method to reduce the error and do the inclination of the line to get the best possible fit. So there are multiple ways where you can do a best possible fitment of your linear regression. One of the methods is the r squared method, but there are other methods as well. So using that, you do a fitment and then draw your line, so that when you have to do the better the line, the better the prediction. The higher the error in your inclination of the line in fitting the scatter, the higher is or lower is your prediction accuracy. So did it answer your question, Vikas? Okay, got you. Thanks, Vikas, for the confirmation. So given this, then we will try to talk about logistic regression, what and why. Right, we just try to understand what is regression, then we will try to say and understand what is logistic regression. So logistic regression produces results in a binary format. Predominantly, unlike what we saw in our previous example, it was a continuous format, but wherever we will have to do your prediction in your binary format, we will linear regression fails. So we will not be able to do the binary prediction using linear regression, and in that spaces you will have to use your logistic regression. So for example, if I happen to ask, will it rain tomorrow? It is yes or no, right? So when I have to answer discrete, it is yes or no, then I will have to use linear regression. So if you have to read this, linear regression produces results in binary format, which is used to predict the outcome of categorically dependent variable. So the outcome should be discrete or categorical, such as zeros or one, yes or no, true or false, high or low. In such cases where our output is binary, then we use logistic regression. Sticking to the same weather example, if I am asking you what is the temperature tomorrow, then it is a linear regression. But if I am asking whether will it rain tomorrow, which has only two values, yes or no, for that you use your logistic regression. So this kind of regression where the output is binary, we will have to use logistic regression. But why not linear regression? Here, since the value of y will be between 0 and y, the linear line has to be clipped at 0 or 1. Here, when we see the linear regression, it passes through it. But our value for logistic regression should be between 0 and 1. So your line has to be clipped either at 1 or at 0, and then we have to proceed. I think we have a question. Let me pick that. Can we use Tableau for doing logistic regression for predictive analysis? Definitely yes, Saurabh. So Tableau at the end of the session, sorry, Tableau is a visualization tool. So if you can pass your data, once you do computation in either R or Python, you do the computation and you feed your data into Tableau, you will be able to do your visualization of logistic regression also. But from a computational standpoint, you might have to use any of your programming languages like your R, Python to get the calculations within logistic regression. So did that answer your question, Saurabh? Oh, okay. Thank you. Thanks for confirming. So here, when for example, if it is of the weather, when it says will it rain tomorrow, then we said it is between yes or no. So it is like 0, between 0 and 1. You will have to clip it to be between 0 and 1. So how do we do that? With this, our resulting curve, when we clip, it becomes something like this, which is logistic in nature. When we clip it and combine it with 0 or 1, this is how we can make it. So which we also call it as a sigmoid or an S curve. If you happen to see, this was the linear thing. When we clipped it at your binary values, it became like this, which is nearest to one of the approach what we use in our regression technique, which is the S curve or the sigmoid curve. Saying this, Here we will have to see what is the threshold value. So in this case, between 0 and 1.5 is your threshold value. Any value which comes above 0.5 less than 1 has to be put at 1, and anything between 0 and 0.5 has to be downgraded to 0, so that the value or the output or the regression or the prediction out of this can be binary in nature. So with this, the threshold value indicates the probability of winning or losing. So I think we have a question. In which cases we can use logistic regression, Sagar? Okay, threshold, sir. Because you might have to rephrase your question. Sagar, to answer, like I said, we can use logistic regression in various use cases, especially when you have to see your output as binary. Like one of the example which we are discussing is the weather. Will it rain tomorrow or not? So the second thing is based on the age, will a customer buy or he will not buy. So there is nothing called as he will half buy or he will quarter buy, right? If he buys any product, he buys, which is one. If he does not buy, he does not buy, it is zero. So in those cases, we will have to do logistic regression. Okay, and Abhishek has a question. But when we divide our data into train and test parts, we are going to get some percentage of correctness only, right? Yes, Abhishek, in all machine learning algorithms, the target is over a period of time of training. It can go to 100%, but the intent is the correctness might start initially at a lower percentage. It may not be at 100% always. Okay, and coming to Abhishek, did it answer your question? Okay. I'll wait while waiting on Abhishek's thing. What? Okay. Okay. Let me repeat the things for you, Abhishek. So when we divide our data into train and test, we are going to get some percentage of correctness only. The nutshell answer is yes. When we train our data model and we try to test, our correctness may not be 100%. It will be always less than 100% to start with initially. With time, with increase in data and with increase in or fine tuning our model, the percentages gradually go and reach near to 100%. Did it answer? Okay, then how can we say that answers come with only yes or no? Okay, when we say 99.94, then it is almost equivalent to 100. If it is 0.0002, then we are trying to say it is near to zero. That is where we are trying to do the act of rounding off, and we are getting it. You will never be able to say, see, if you happen to use scikit-learn, then they do the rounding off within the functions itself, and you get zeros and one. But if you use the statistical models, it will try to give you if there is any quotient of error left into that as well. But from an end user's perspective, anything above 99.99%, we take it to be 100. Anything below less than 1%, we take it to be 0. That is how in case we do that. But if we get 89% and 11%, then we will have, if you are seeing that if you get 89% and 11%, then we still have to fine tune the data to get to a stage where it can become more than 90%. Otherwise, the model is not completely accurate. The accuracy level is to a greater extent. That is what it means, Abhishek. Okay. And okay, thanks. So coming to Vikas's question, what is the threshold value in general? So if it is logistic regression, usually we take the in-between value or the 50% value as threshold, because the intent here is to bring your output in either of the buckets. So usually it is 0.5 if it is 0 and 1, yes or no, in between. that is the way we get that Vikas. Okay, I think we answered Vikas's question and we answered Abhishek question. Oh, okay, thanks Vikas, thanks Abhishek for confirming. Okay, so coming to our logistic regression. So with this, the threshold value indicates the probability of winning or losing. So, but how do we mathematically do this? We have a equation which we derive. So we know the equation of straight line is equal to y is equal to mx. So then let's try to reduce the linearity quotient or the straight quotient, because the straight quotient, the range is from minus infinity to plus infinity, while in logistic regression we need it to be between 0 and 1. So when we have to make it between 0 and 1, this is, we will start with 0 to infinity, that is y by y minus 1. When y is equal to 0, then y becomes 1 to infinity, and similarly the other way around, when we have to make it minus infinity to plus infinity, we will add this into the log, we get this equation. But the good part is we just have to know the math of this particular thing. When we are using the machine learning algorithm like logistic regression from scikit-learn or any of the libraries, this mathematical formulas are taken care within the function. We will have to pass the parameters and get the output. So once we have that, then we just do the fitment and get the output. So if this is logistic, then let's try to see at a very high level, which we have already tried to compare, how is logistic and linear different. So in linear we get continuous variables, while in logistic we get categorical variables. While linear regression tries to solve regression problems, while logistic tries to solve classification problems because it is 0 or 1. And in linear regression the line is straight line, that's the reason why we call as linear. And here we have a logistic, we have an S curve, which is the indication which we saw. So that is how it is, that is how both linear and logistic regression differ. So it is continuous versus categorical versus regression versus classification, and straight line versus an S curve. So saying this, let's try to see some day-to-day use cases on logistic regression. So logistic regression, like we started off our discussion, one of the evident use case is our weather. So weather predictions, where we try to see, for example, this is the weather prediction of a given city, and we have the temperature, we have the humidity or rain forecast. So the temperature prediction is the linear quotient of it, while the rain prediction is the logistic quotient of it. And if you have to talk about the classification, there are so many classifications, or basically Python in scikit-learn helps you to do a multi-class classification. So if you have to take this example of vertebrates, we have an amphibian, bird, fish, mammal, and reptile. So if you have to see whether a crow is a bird or a mammal, so this is a classification which we try to see. And if you have to see from the healthcare, determining the illness for a given patient based on the various parameters is other classification. So an ideal example is when we do a blood test report, right? When we get our blood test or blood sample test report, we have two columns, one is your value and one is the reference value. So if our value is in range with the reference value, we say it is okay. If it is out of range, it is not okay. So these are the two classifications which helps us to determine whether a patient is ill or not ill. I think we have a question. Let's try to pick that. Does it have a confusion matrix? Yes, definitely confusion matrix is always there for us to see how valid is our model. We can use confusion matrix for various machine learning techniques or algorithms, Abhishek. Okay. Somebody has raised their hand. Any question, guys? Because I'm not able to see. Okay. I think Abhishek was the person. So, Abhishek, did it answer your question with regard to confusion matrix? Okay, thank you. Now, let's try to see how to implement logistic regression. So, when we say logistic regression, like any other algorithm, we have these 5 steps where we will have to collect the data, analyze the data, clean the data, which is called as data wrangling, train and test the data, and then do the accuracy check. I think we have a question. Let me pick that. I keep the hand rising only. Okay, okay, no problem. Okay, so coming back, the implementation of logistic regression, we said like any other algorithm, we have this 5 steps where we do the data collection, then we do the data analysis, then we do when we say data collection, it is basically sourcing of the data to see where we can get the data required for our problem solving. Then we do your second step, which is analysis of our data or analyzing our data, where we try to do some visualization, try to see a fraction of the data, or see the data in various variations, so that we can understand how to proceed further. Then we do the data wrangling. When we say data wrangling, it is predominantly cleaning of the data. So when I say cleaning of the data, we might have the data which are probably with missing data, or data which is not completely filled, or a fraction of the data, continuous data, static data. All these enablers have to be addressed as part of your data wrangling. Then we go ahead and do training and testing, where once we have a data which is clean enough to be consumed, we particularly fit that into our training model, and then we do the testing, and then we do an accuracy check of the model before we can use it for any of our applications. I think somebody has a question. Let me pick that. Do we use logistic regression versus deep learning like ANN? Vishnu Reddy. Okay. Vishnu, see, the deep learning artificial neural networks is a subcategory within machine learning. So logistic regression is a machine learning technique. So many a times post logistic regression, if we need further classification, we might use ANN. But if you have to see the other way around, it might be too much of engineering. If you say I do my ANN first and then do the logistic regression, probably that is not the way you can approach her. It is always that if you have to do, try to do with your machine learning to whatever extent, and whatever the quotient which machine learning saturates, or it determines that it cannot model itself to be anything better, then we will go into your deep learning. Okay, so that is the approach what you get. How do we analyze the data? When we say analyze the data, when we pick the example, I will also talk about it, Anushk. But in general, when we say data analysis or analyzing the data, it is trying to visualize. So for example, if you have 10 columns of data, then you are trying to see which columns make or which columns will give us some direction in helping us to solve the problem. So it is predominantly trying to understand the depth or gravity within the data before it can be cleaned, so that it can be modeled and checked for accuracy. Did it answer your question? Okay, I'll take it as yes. If not, you can write back. Okay, let's try to see a simple example where we will talk about the survival rate in the Titanic ship. We basically have a large data set, and we all know that Titanic ship was one of the famous ships in its time. which did sink in its maiden travel, and this had a large quantity of people who were on board, and this data gives us immense uh, coefficients for us to analyze. So let's try to take that data and see how we can see the model what we were discussing. I think we have one other question. Okay. The parameter to consider for cleaning and training. Yes, yes, it answers my question. Thanks, Ankush. Okay, let me show you the data what I have for the Titanic ship. So if you see this, there are like 3 plus 3, 6 plus 3, 9 plus 3, 12 columns of data. We have the first column as the passenger ID, the second column as survived. If it is 0, if it is not survived, if it is 1, it is survived. Then we have P class, where the class in which the people traveled. There are three classes: 1, 2, 3. Class 1, class 2, class 3, like your first class, second class, and third class. And then you have the name of the person, then you have the gender, then you have the age of the people who traveled, then you have SIB, SP, which means that the number of siblings who traveled, then you have PE, which means the number of siblings who traveled, and you have the parks, which is the total number of parents who traveled, if it is a kid. And then you have your ticket number, you have your fare, and the cabin details wherever the people were traveling in the cabin. And you have something called as embarked, where you have three things, where S, C, and Q. These were the three places from where the ship uh, did allow people to board the ship. So we have a question. Let me take that. What are we doing? Import math. Does that mean we are importing mathematical function? Abhishek, let me come into the code. I'm just now seeing the data. When we are seeing the code, I will go through it individually. Okay, and in one liner, yes, import math is a library within Python which has mathematical functions. We are importing that as well. Okay, did it answer your question, Abhishek? Okay, so seeing this data, let's get into our Jupyter notebook. Try to see how we can import the data and how we can model our data. So if you have to see, let me try to use my libraries. We are importing this libraries: pandas, numpy, cbarn is your plotting library. Then we have our matplotlib, which is also the plotting library, and we are importing the math function. So once we have this, we will define our data frame, where we using pandas, the data what we said titanic.csv, which we did see. We will import that, and we will see the first 10 lines of the data. So if you have to see this, this is the first 10 lines of the data. I think we have somebody having some question. Okay, okay, yes. Now this, once we import this library and once we take this data into data frame, let's try to see some analysis on this. If you have to see what is the total number of passengers in this data, we just try to see the using the length function on the Titanic data using our index function. And if you see this, there are like 891 passengers. The number of passengers in the original data is 891. So if you have to see in the Excel sheet, predominantly we have this 891 records. Okay. So 892 including the header. So once we have the data, we said that was our first step of collecting the data. And if you have to see, our next step is analyzing the data, right? So I think we have a question. Can we use logistic regression for building a chatbot? Okay, so Sagar, if any of your questions or your approaches for any of the replies should be binomial in nature, then you can use logistic regression on some of the data which is collected. But many a times a chatbot has unstructured data, so logistic regression might not be a good fitment for answering. So it is like customers asks you what is the store timings, you are saying you are the bot will reply as soon as possible saying that I don't have it anything, right? Probably there can be more continuous flow of reply saying that let me check or let me connect you to the right people, might be a better approach in a chatbot than trying to shunt off the customer with binomial replies. Okay, so did it answer your question, Sagar? Yes, logistic regression falls under supervised learning. I don't know when you mean structure learning. I don't understand what is structure learning. But if you have to say, logistic regression is a type of supervised learning under classification. Okay. Thanks, Sagar, for confirming. So then what we said is the second step after we get the data is analyzing the data. When we say analyzing the data, what we try to see is, let's try to see and using our Seaborn library, where we have defined it as SNS. Let's try to see the number of people who have survived, where one is survived while your zero is not survived. So if I have to run this particular thing, so basically the number of people who survived are around 300 plus, while the number of people who did not survive are around 500 people. And if you have to see one other dimension of it based on the gender, then let me do the same thing with the count of plot. I bring in a parameter of gender using who, and if I have to run this particular thing, then I will get that the number of male people who did not survive are higher, while the number of female people who survived are the number of females who survived are higher versus the number of male who did not survive. If you see this, the blue graph, which is your male, did not survive, while the female graph who survived are higher. I think we have one other question. Can you please scroll to? Yes, Abhishek, I'm scrolling. I'm scrolling. Yes. Okay. So this was based on the parameter of gender, and if you have to see based on the parameter of the class of ticket what they have bought, if I have to run this, so if you see this, basically the class 1, class 2, class 3, the three classes what we had, and this is our survival rate. So predominantly the class 3 people did not survive a lot, while the class 1 and 2 survived comparatively higher based on the total number of people who were there. So if you see in class 1, these were the number of people, so around 60 or 80 people did not survive, while 140 people survived. While if you have to see the class number 2, around 100 people did not survive, while the same number of people survived. And in class 3, around 350 people did not survive, while around 100 plus people survived. Now with this, let's try to see the plot of what is the age of the people who are there on the ship. So if you have to run this, you see the maximum number were between 0 to 40 years. So between 0 to 20 there was around 50-60 people, and between 20 to 40 were the maximum number of people who were available. So this is what we have as part of the age. If you have to, I think we have a question. How did we get the two graphs? Okay. What host function do we will do? What host function will do? And how did we get the two graphs? So let me try to answer Abhishek's question. So Abhishek, we are trying to analyze the graph from the Titanic data set what we have, and what we are trying to do here is, if I have to see here when the two graphs what we have here, if you are mentioning about this graph, this is a graph where we are trying to see the spread of age. Let me show you. So this is basically on the Titanic date. On the column age, I'm just trying to plot a histogram. So based on that, based on the age, it is trying to say the overall age range was between 0 to 80 years, and the number of people who belong to this age. So that is how you plotted this histogram. I think we have one other question. uh, I'm not able to see the code. Okay, I got a call. I missed 5 minute session. What is the name of the application that you are using now? Saurabh. Okay. Sorry, I'm asking a basic question. I'm new to data science. Okay. Saurabh, what we are trying to do is basically we are trying to take the Titanic data, the Titanic movie, what we have seen, the ship which carried a lot of people, and when it did sink, there were few survivors and there were few people who lost their lives. So with that data, we are trying to analyze what is available, and we will also try to see how regression, linear regression fits into it to see the model. So that is what we are trying to see, and I'm not able to see the code. Okay, Abhishek, so if you happen to see this, let me try to bring and make my uh, thing little bigger. Okay, now is it better, Abhishek? Now you are able to see the code. So I'm using a Jupyter notebook, and every line what I do, I'm just highlighting, and the output here, if you see, the in is the code and out is the output. I think we have a response. Okay, Kiran, can you please show the code and let us know how to get two separate graphs? We are just giving the category as survived only. How come dying record comes? Okay, let me help you with that, Abhishek. So if I have to go to my data, which we have it here. Okay, now what we said here in our data, we have this survived as our column B, and in this we have given a numerical value 0 and 1. Now 0 means he did not survive, 1 means he survived. And for example, in this case, the person who traveled in this third class, whose name is Mr. Owen Harris, did not survive. Why, if you see this second line, the person John Bradley survived, and he is from first class. So that is the way we have this data, and I am using this column survived, and I am trying to correlate this column with many other things where we did see based on our age or based on the gender. Okay, so the functions within Python using our pandas. See, what we did is we got the data into this data frame, which is Titanic underscore data, and on that we are passing our variables to get various graphs. And if your question was more to do with this, where we said supervised and gender with Titanic data, this SNS underscore count plot is the graph generator. The SNS is the Seaborn library. Under Seaborn library, we are using the function called as count plot. For this function count plot, we are passing our x value with supervised, and we are asking it to categorize by gender on the data, which is Titanic data. That is how we are able to generate the graphs. Did it answer your question? Okay. Before histogram, the bar one. Yes. So that's where I did check this. So did it answer your question? The bar one. This the histogram is here. The bar one is from your Seaborn library, under which you are doing the count plot function. Okay, so hope this answered your question, Abhishek. Okay, let me take it as yes. Okay, thank you. Now that was one analysis. Now let's try to see This was our histogram or the plot graph based on the age. And if you have to see a similar thing on the fair, so we had various fairs here. Let me try to run my thing on the fair. So if you have to see, between 0 to 100 was the maximum fare. There were few instances of 200 or 300, and the number of people between 0 to 10, if I'm right, so had paid the maximum fare or the maximum collection of the fare, and that was the thing. Now let's try to see the data itself. We are saying Titanic data underscore info or dot info basically, which gives us the information about this data. Here it is saying there are 12 columns in total, 890 values. Then we have the passenger ID, the survival ID, the age. We have like 714 rows have age, while the remaining does not have. There are 204 rows which have the cabin details, the remaining does not have. While in embarked, there are 889 columns which have the data, while the remaining two does not have. So the function dot info gives us the details of the data. Then if you have to see the based on the siblings, what we did see one other column. I am just passing SIBSP into the Titanic data. So the maximum number of people were without siblings. There are few people here which we have the details. This is all for our analysis. Once we have this analysis, we did try to see the data in various shapes and forms. Then our going back to our presentation, the third step was trying to see how we can the second step, and basically here we did our creating different plots to check the relationship, and then we did different plots to check the variables, so like where we did the gender or the class of the things. Then we will have to do our next step, where we will do our cleaning. So when we say cleaning, basically there are so many columns within the data which does not have the value. So when we did see our describe, we said that there were few columns within the cabin which was not filled with data. There were columns in age it was not filled with data. So those columns have to be addressed before we can address it. But first, if you have to see this, let's see which are all the columns in this Titanic data which have no values. If I have to run this, you see this, these are all the columns, or these are all the things which are available with no data. Then the true and false indicate there is a value or no, there is no value. And then if I have to go and see the summary of this at a summary level, if we run this, basically it gives that in passenger ID or survived or P class, all of them have the data, while in age there are 177 records where there is no age populated, and in the cabin there are 687 records where there is no cabin details populated, and within the embarked column there are two records which does not have the value. After this, what we will try to see, the same thing, let's try to see visually using a heat map. So if I have to use the heat map, I will use my Seaborn library, calling the heat map, passing the data from my Titanic data, and let's try to run this. So if you have to see this, here the column which is in age does not have few records, and the things with the cabin does not have, and the one which embarked, because only two records, it is just we see a light yellow color line here. And that is how from a heat map perspective we are trying to see this particular thing. And if you have to see the same thing based on the class using our candlestick approach, we get to do a box plot and pass the values of age and class. And based on the age and class, we get to see this is the first class, second class, and the third class, and the age between 30 to 50, in the first class, 25 to 35, and 20 to 35 in the third class. That is how we get to see. Now with this, let's try to see what data which we will have to clean. We said that basically, right? We have some data which we will have to convert the strings into our integers. That is one thing. And wherever we don't need the data, also we will have to drop that particular thing. So one of the thing is the cabin, which predominantly 687 records out of the 900 records does not have cabin. So there is no point we keep in that. So we can go ahead and drop that particular thing from our data set or our data frame. And if you have to run the records, we will get our new data frame without that cabin details. Then we will also try to drop in as in place is equal to true. Let's do that. And then if you have to see the data, how clear it is, when we have to see the same heat map which we previously run. Now if you see this, all the values which were of not available, we did clean that particular data. So our heat map now is completely clean. Then if you have to run the same thing using the same value what we did, Titanic data with the summary, let's run this. So if you see the columns which we are using now has all the values, so there is no columns without values. And we are trying to see a few records, two records out of that data, and these are the two records. Now in this, what is happening is, where we have this gender or sex, we have a male or a female, which is a string value. And regression models, or any models for that matter, cannot handle the strings effectively, or we will not be able to do any modeling with strings. So we will just convert that string into a integer. So how do we do that? Basically we are trying to convert that into, if it is male or female, by 0 or 1, and then we try to run this. So our male and female got converted into an integer. Similarly we have embarked, which is also a it is a string which we will convert into the string, because we had three values here. There were three places from where the people boarded the ship. So we will use that, and we will convert that into the numbers 0 1 2 3, and we get that q, s and c values. Once we do that particular thing, we also will drop the first second class, because we don't need that. Or basically there are three classes, because if you say if it is 2 or 3, then obviously the one which is 1 become which is not 2 or 3 becomes the first class. That is how we reconvert that. And whatever the fields which we have changed, let's, okay, we have changed. Let's try to concatenate all of them, and try to see our new data set, which is the 5 records from the new data set. So this is how we get this particular data set. And then we will drop the values which we don't need, like the male which we had the gender, the embarked which we had SC, the passenger ID which is just the numbers 0 1 2 3 4, the name which is a pure integer, which is a pure string, we don't need that. And the ticket number which we have, which is a combination of integers and values, which is also a string format, just we will drop all of this from our data set, and we will get a data set which is just integer in total. So if you see some records, the survived, p class, age, sibling, parts, fair, everything became into an integer. Oh, I think we did not do the p class. Let me run this. Okay, so once we have this data which is cleaned, then we will have to do our next section, where we said train and test. So this is where we try to build the model, train, and try to predict the output using our test data. So let's see how we will use the functions which are available from some of the Python libraries to train our data. So when we said this regression, we will have to take both the dependent and independent variable. Now we have our x value where we say survive, and the y value, which is basically our y value is a dependent variable, and your x value is independent variable. So basically using this we will try to run this, create the data for our x and y, and we will try to split it. We will have to split this train and test using the scikit-learn cross validation. We will use the import train test. We will run this, and then we will basically run the test and train using the parameters which are available as part of this train test split. Then we will use our logistic regression. Logistic regression is also function within your scikit-learn under the group linear model. So you have sklearn.linear model import logistic regression. We are just importing that, and we are assigning variable log model to logistic regression. Once we have our log model defined, we will have to train that particular thing. So we will use that log model dot fit using our x train and y train parameters. Let's try to run this particular thing. We see the various parameters which have come after training. I think we have a question. Let me pick that. Can we tell the value, the meaning of x value, or what is train split? Okay, let me explain both of them. So the x value here is the independent values, and the y value is dependent, because we are trying to predict whether a person survived or not survived based on your other values in your data set. So if you see, our data set has this, and we have your first class, age, sibling, parch or fair. All these values are available based on this independent variable, which is our x. We are trying to determine or predict our dependent variable, which is survived. So that is the thing which is survived. And coming to one other question where we said x train and x test. So as part of any machine learning exercise, what we do is we first have to train the algorithm feeding the data. Excuse me, guys. So whatever the data set, sorry. So whatever the data set we have, we will have to split the data and train the model, and then test the model against the available data. So that is that activity of doing. We do this using this train and split the data. I think we have some response. Okay. Mm, Titanic data drop survived access. What does this mean? Okay. So here what we are doing is, let me show you, Abhishek. Let me close this. So like I showed you here, this is your data frame, right? We have survived, p class, age, sibling, parch, pair, male. All this data we have. What we are doing is, other than supervised, every other column becomes, which is independent, is your x value. That's why x is equal to Titanic data without supervised, while your y is just supervised. That is why we do this. So your x value is all regression is to predict the survival, whether a person is is survived or not survived. So hope that helped you, Abhishek. Okay. So once we have this log model where we did run our model, we will try to do the predictions using that predict function within our scikit-learn. So we do that predict and then run a classification or confusion matrix on that particular thing to see how our predictions work. So this is the values which you get, but let me try to explain you in detail. When we run the confusion matrix, we get a matrix of 2 cross 2. This is your confusion matrix where we say 105 versus 21 plus 25 by 63. If we have to see this, let's come here and see how does this work, which is basically the actual versus the predicted. So in actual, if you have 0 which is positive, 1 which is negative, and in predicted if you have 0 positive and 1 negative. So if this is actual and predicted both are positive, then this is called as true positive, which is the actual condition is positive and it is truly predicted as positive. The model has truly predicted as positive. And if it is false negative, where the actual condition is positive while it has falsely predicted as negative, which becomes fn. I think we have a question. So we are basically dropping all the values where supervised is 1. That means the people died. Abhishek, we did not. Okay, I think you got little confused there. Let me go back. I will show you. Okay, I will also show you the Excel sheet. In Excel sheet, we have the value already. This is the history of data, right? In this, we already have zeros and ones. We did not drop any ones from this column. What we did drop is basically here we have so many other columns, not the rows. So many columns: survived, P class, age, sibling, parch, fair, all these columns. So what we are saying is our X values can have all other columns other than supervised, which means we are just dropping the column supervised for our X values, and for our Y values, we are just retaining the column supervised, which is only this column is our supervised. That is the thing when we are doing it here for our training. Okay. Thanks, Abhishek, for confirming. Okay, now when we see that confusion matrix and we have to see the accuracy, if you have to see from our deck what is accuracy, accuracy is the true positive plus true negative. Here the true negative is the actual condition is negative and it truly predicted as negative, and TP is true positive where the actual condition is positive and it truly predicted as positive. Basically the accuracy is the sum of this by addition of all of this. So with that value we get 76 or 78.5. So the accuracy of this model is just 78%. Probably we need more data to get it to an higher level and use this model to predict the survival rate using the logistic regression. So this was our humble effort to see how we have a small data set of Titanic ship and trying to model a logistic regression and trying to predict. Similarly, we can take one other use case where we will do the SUV data analysis. So what do we do here? Basically, a car company has released a new SUV in the market, and using the previous data what it has about the sale of their SUVs, they want to predict the category of people who might be interested in buying this. I think we have one question. Do we show some, can you show the last some lines of the code? I will show that, Abhishek. So this is the thing. From scikit-learn, we are calling the confusion matrix. We are using that confusion matrix, passing the y-test and predictions. We get this array, which is our confusion matrix array. and we, with the confusion matrix array, we are trying to run the accuracy score, which I explained now, to get what is our accuracy quotient, which is 0.78. Okay. So coming to our second use case. Okay, I think Abhishek just replied. What does the accuracy score function? Okay, Abhishek, let me repeat that. So we have something called as confusion matrix, which I said. Let me go to my previous slide. And if you have to know the confusion matrix score, accuracy is one of the term which helps us to determine. How do we get the accuracy score? This is the thing. So basically we have two things, where which is the actual values versus the predicted values. Now in actual we can have two things, right? Positive or negative, 0 or 1. In the predicted also we can have 0 or 1. When your actual class and predicted class have the values both 0 0, then this is the true positive case, where the actual condition is positive and the model also predicted as positive, which is called as true positive. When the actual case or actual condition is positive and the model predicts as negative, then it is false negative, which is Fn. If the thing happens to be actual condition is negative and it falsely predicted as positive, then it is FP, false positive. If the actual condition is negative and it truly predicted as negative, then this is true negative. Then using these values we can calculate the accuracy, where accuracy is the sum of true positive plus true negative divided by all the four things: true positive, false negative, and true negative. In this case we don't, this is the math behind that accuracy, but our function accuracy score from scikit-learn matrices will calculate us, and passing the parameters from that, we get the value at 78.78, which is 78%. Okay, if x variable has a categorical and also y variable has a categorical, uh, so basically if you see depend in that case, if both are done, then we will have to do a dimensional reduction, get one to categorical and one not to categorical, and then apply the regression, Newton. That is the way which we can do. And answering Abhishek's question, yes, accuracy score is a function within the scikit-learn, but the math is what I explained. Okay, hope it answered both the questions. Oh, okay, got it. Now coming to our second use case, which we said, like how we took the previous use case of Titanic data, we will take data on the SUV data analysis. I think we have another question. Okay. So Newton, basically when if we have the data where both the values are categorical, we will have to do a dimensional reduction, where we convert or we get the data diminished to one value being categorical and one other value being continuous, and then run our linear regression. And then once we do keep doing the dimensional reduction, once we get to a value where we have either cases, then we can use logistic regression. If not, we cannot use logistic regression directly. So did it answer your question, Newton? If in nutshell, if you have both categorical values, for x and y, logistic regression is not the approach. Okay, got it. Thanks, Newton, for confirming. So getting to our next use case or next example. So this is again based on the SUV, the prediction to see what category of people will buy the newly launched SUV. So let me try to show you the data what we have for SUV. So we have this data where we have an user ID, the gender, the age, estimated salary, and from the previous history of buying the SUV, they have the indicator 0 is they have not bought, 1 they have bought. So let's go to our Jupyter, try to import our data. So where we first import our libraries, import NumPy, import Matplot, and import Pandas. So let's run this, and I have my data set, which is the SUV predictions. If I import that data, let me import the data. And if I have to see this data from the data set what we just imported, so this is the data what we have, the top 10 records, the top 10 records, the user ID, gender, age, estimated salary, purchase. Then we will go into assigning the X and Y, where here X is your data set using our function iloc. So basically we will have to need the data for our X, which is the iloc is the index. So if we are saying this, the column 2 and column 3, which is your age and estimated salary, and here for your Y we are trying to use the prediction, which is your purchased, which is your fourth column. And that is how we are building our X and Y. If I have to see my X value for a minute, so this is, oh okay, uh, let me run my X and Y, and let me try to see my X. So if you see this, the age and the earning is my X and Y. And if I have to see the Y, this is my Y zeros and ones, where whether he has bought or he has not bought. Then we will use the same train split model. I think we have a question. Let me pick that. In the case of gender, we just have two values to convert the string into numeric values. What do we do when the field has thousands of values like city? Okay, so when you have thousands of fields like your city, you probably should not use that to be part of your regression if possible. If the idealistic case, anything which is more than 3 or 4, it is better not to consider to be part of your X and Y from a logistic regression perspective. Because if you try to convert it, the complexity of the model will increase, and proportionally your accuracy quotient keeps diminishing. Here, if you see, logistic regression is predominantly to find values which can be your binomial. So that is the one of the way which we can address when your values are multifold, like the example which you picked, city. Did it answer your question, Vishnu? Okay, thanks for confirming. Now, like how we did when we were doing the Titanic thing, we will do the scikit-learn from the scikit-learn module. We will use this train split, and then we will pass the parameters into the X train, Y train, and then we can do one scaling. Basically, this is a standard scaling procedure where either to scale up or scale down, so that if you don't have good amount of data, we can use this standard scalar functionalities before we can do our fitment. So when we say fitting, it is basically the training. So we did X train with the fitment and transform the X train. and then we will use the same logistic regression model using the import logistic regression approach, and then we are using the classifier within the logistic regression, and these are the parameters which we get out of our logistic regression, where it gives you our random state details and the class details. Once we have that, let's try to predict. And if you have to say, we are predicting, and we will try to see similarly the accuracy score. Here if you see, the accuracy score is around 89%. Previously it was 78%, if I remember, in the Titanic score or the Titanic data, while in your SUV prediction, the accuracy quotient at this point of time is 89%. So if you have to feed this model with new data, the accuracy with which we can predict whether a person will buy or will not buy an SUV is at 89%. So what is the test size field in the test? Oh, okay. Ankush, basically in the test size, if you have to come here, you are asking about the split. Basically, uh, let, okay. Let me come back to you, Abhishek. Can you show that? Yes, I will show that. And I'm trying to see, Ankush, the test size field in the test train data. If you are referring to this particular thing, right? The train test split. Uh, uh, what is that you said? Size field. Okay. Oh, this test size. Okay. So this is one of the parameter which helps you to increase your data set continuously. So with the intervals of 0.25, we are trying to increase our testing quotient. That is what is the parameter test size. And coming to Abhishek's question, here what we are trying to do is, we are scaling up, and we are directly trying to see what is the accuracy on the prediction level, right? So that's why we do a classifier, we predict our values, and on the predicted value we run our accuracy score, like what we say, the we did see this particular thing, right? The confusion matrix, true positive, false negative, false positive, and true negative. That values we are trying to pass into the accuracy score using the Y test and Y predict, and then we get this score. So that is the way we get our accuracy score. Okay, what is scaling? Okay, so when we say scaling, basically scaling is to either, if you have a very little data or too much of data, we can magnify or we can reduce, so that our models can work with that increased or decreased data set. That activity of doing it is scaling. Okay, so that's the thing what we did try to see from our SUV data analysis. Saying this, I think we did try to cover, but we will see what is the roadmap in becoming a data scientist. I think we have one other question. Let's try to see that. The testing, does it use the data from data set, or it creates a new data for testing? Okay, there are, when you say test, if you are using a standard model, and if you are not using scaling, it will not create or anything, it will not create any data. If you are using scaling mechanisms, then the test data is randomly created so that you can scale up or scale down, Ankush. Okay, so hope that answered your question. Okay, thanks, Ankush. Now, if you have to see the journey towards the data scientist, predominantly this is a job description from one of the MNCs. So you see that basically they would have the need of the hour is predominantly on various parameters in statistics, programming, and especially in extraction, data wrangling, and data visualization, and machine learning algorithms. So a right combination of all these things is needed uh, for us to do some uniquely blended algorithms. So I think we have one question. Let me pick that. How can we extract the internal code and maybe weights used for each field while coming up with prediction? Can we extract the internal code? Uh, I want to know. Abhishek, can you repeat what was the question you said which you did not get it? Is it with regard to scaling? Just confirm me while I am trying to answer the others. Which could provide no data? Sorry, which could? Okay, Abhishek, I'll come to the scaling. I will talk about scaling, and if you have to see about Sagar, Sagar is asking about which cloud provider do data scientists most used in the world. Okay, if you have to see, AWS is one of the things, followed by Azure and Google ML, but there is a good amount of usage of all these top three cloud providers: AWS, Google Cloud, and Azure. Sagar. And coming to Nikhil's question, can we extract the internal code and maybe the weights used for each field while coming up with prediction? Once the model is trained, how to use it in future with incremental data and it can be trained? Okay. So Nikhil, see, a model is a learning quotient. Basically, like how we, as humans, we learn and we get trained. So the classic example which I always pick here is the cycle example. When we first started learning cycling, it was basically our initial learning, and once we said we have completed the learning, it went into a mode of training where we tried few other activities like cycling at a slow speed, or cycling at a faster pace, or rebalancing ourselves. All these things were the achievements after lot of data, environmental data sets which we gathered. So similarly, for a machine, when we say a model is trained, it is a continuous learning process, and with time the training gets better and better, and the accuracy of predictions improve. So that is how we say machine learning is not explicit programming, it is a continuous learning approach to make our outputs better. Okay, so steps to deploy model in production. Somya, sorry, Nikhil, did it answer your question? And coming to Somya's question, steps to deploy model in production. So predominantly it depends on what you are trying to deploy, Somya. So if it is a simple predictive model, and if it is on a cloud, once we have the remaining 5 steps of data collection, data cleaning, modeling, testing, we do a simple production move where we do an application build or rebuild, and then use it for end user consumption. But if it is a standalone intermediate model, we keep running it as the Python code or the R code for it to get trained to a better stage before it can be deployed to a production instance. So that is the way which we can do. Coming to Abhishek's question with regard to scaling. So Abhishek, scaling is to reduce or increase the data set for us to train, and there are various ways to increase the data set or reduce the data set. Dimensional reduction is an approach where we use to reduce the data set, and we use the random quotient approach to increase the data set, where the data is created randomly for our model to get testing to get better trained, and then based on this trained model we try to see if the accuracy is increasing or decreasing. If the random data set is not increasing or not helping us to increase the accuracy, then there is no point in scaling, where we will have to depend on the actual data which is coming. So that approach of increasing or decreasing the data for our training the model is called as scaling. Did it help answer your question, Nikhil? Sorry, Abhishek. Abhishek, the Jupyter Code notebook you will have to write to us, and all these things once you enroll to most of the sessions what we have, you get the complete content and hands-on sessions. So coming to Nikhil, but how to use the model in production with incremental data is your question, and how do we develop interface of our model for an Android application is Ankush data. Okay. So Nikhil, basically model in production with incremental data means the trained model becomes part of your overall application, and as the data keeps changing, it is internally getting trained. So you don't have to do any additional step, but the trained code itself is put into your hosting application or the final application bundle. And can we develop an interface of our model for an Android application? If you are talking about saying can we have machine learning applications for your Android operating system, the answer is yes. There are many tools which are available, where once you complete your Python coding, you convert that into the means which can be plugged into your Android, and then you can use it. But for Android or iOS, the procedure will not be as straightforward as what we use for Java or any other things. There is a sequence of procedures which needs to be followed to make any of the algorithms compatible with phone operating systems. Okay. Coming to our data scientists, we did see this particular thing. I think somebody has one other question. Okay, Ankush replied. Okay, thanks. Okay, and with all these things, we basically have many of our courses which are available for enrollment on edureka.co. So basically we have the Python certification, machine learning certifications, deep learning certifications which we have it. And there are various courses with fee structures, and real-time projects which will be part of our overall thing, which helps us to keep up with our changing requirements and get market ready for our career shifts or career hops. Okay, so this was an humble approach to give us a brief background on how do we use regression and what is logistic regression. So if you have any questions or anything, we have a community section on edureka.co. Feel free to put in the questions, and we will be more than happy to reply on that. Okay, any questions or anything? Okay, I I hope we enjoyed the session. Thanks for attending it. Thanks, everyone. Thanks for your time. Oh, thanks, Ankush. Thanks, Abhishek.